I'm Paul Possa, frame grabber product specialist at Euresys. First, let me quick walk you through today's agenda. I will start with a brief overview of our latest products. Then we will take a look at the Coaxlink QSFP28. I will explain what are the main characteristics of and performance of this board. After that, I will cover key features of our frame grabbers. I will summarize the essentials like camera and illumination control capabilities, DMA flexibility, acquisition stability thanks to the onboard frame buffer, hardware acceleration of pixel processing, and software and SDK environment. Finally, I will present what's coming next in our roadmap. So let's start with an overview of the Coaxlink frame grabbers and our latest products. So the Coaxlink series is a family of Coaxpress frame grabbers targeting high-performance machine vision applications. With this family, we cover a wide range of Coaxpress configurations, going from 6p6 with 4 and 8 connectors, 6p12 with 1, 2, and 4 connectors, and also Coaxpress over fiber, which uses fiber cables to transfer images from camera to frame grabber. A new member of the Coaxlink family is the Coaxlink Quad 6p12 DF, where DF stands for data forwarding. This is a specialized frame grabber with two main functions. The first one is to receive images through 4 6p12 input connectors and transfer these images to the host PC by its PCI Express interface. The second function is to forward these images without any delay to the next DF board with its 4 6p12 output connectors. This allows us to create a daisy chain topology where the same image coming from one camera is distributed to multiple PCs. The objective of this configuration is to scale up the processing power of the inspection system. Then we have the new Coaxlink Quad 6p12 3D LLE. This is also a highly specialized frame grabber with an onboard laser line instruction for 3D profiling. The idea here is that we project a laser line over an object. This laser line will describe the profile of the object, and the frame grabber will detect the laser line and compute its relative position in the image. By taking successive images from the object being scanned, we can then recreate what we call the depth map, where the pixels represent a position in a 3D space. The advantage of this approach is the high performance, because we process the laser line directly in the frame grabber's FPGA in real time. So we can provide depth maps as fast as the camera can provide images. Then we have the Coaxlink 6p12 to QSFP plus converter. As the name indicates, it converts a Quad 6p12 interface into a Coaxpress over fiber QSFP plus interface. With this product, we can take the advantage of both worlds. In the Quad 6p12 side, you can interface with a large number of Coaxpress cameras available in the market. And at the QSFP plus side, you can use very long fiber cables to connect to a Coaxlink QSFP plus frame grabber. So still in the Coaxpress over fiber context, this is our brand new product, the Coaxlink QSFP28. The Coaxlink QSFP28, it's a 100G coax crossover fiber frame grabber that can support up to 12.5 gigabytes per second of camera bandwidth, which is 2.5 times more bandwidth than the Coaxlink QSFP Plus or a quad 6P12 frame grabber. It is equipped with a PCI Express Gen 4x8 and 8 gigabytes of onboard memory for frame buffering. Besides the high-speed data transfer, the Coaxlink QSFP28 also provides key functions that are essential to create high-performance machine vision applications. Two important features for machine vision applications are the digital IOs and the camera illumination controller available in the frame grabber. Our frame grabbers have a very rich set of inputs and outputs that are compatible with a wide range of sensors and motion encoders. They are accessible via 2 internal connectors and 1 external connector. We have an I/O extension to include additional I/O modules. And we have also a C2C link interface for synchronization between boards. Along with the IOs, we provide an extensive set of embedded tools to handle the IO signals like quadrature decoders, delay tools, divider tools, and height converters. As I mentioned before, C2C link can synchronize cameras connected to different frame grabbers. In this example, we have 8 cameras distributed into 2 separate PCs. Inside the first PC, we can synchronize different frame grabbers by interconnecting their C2C link interfaces. To synchronize boards installed in different PCs, we can use an accessory called inter-PC C2C link adapter. Like this, we can precisely synchronize the acquisition of the 8 cameras, even if they are connected into different frame grabbers or installed in different PCs. So now, the following example gives an overview on how these functions actually work in a high-performance machine vision application. So let's take a simple system with 1 camera, a light source, and a motion encoder. The motion encoder, it's interface with the frame grabber using a high-speed differential inputs, where it will transmit the pulses corresponding to the conveyor movement. We then will use a quadrature decoder tool and a height converter from the embedded toolbox to create events that will drive the camera triggering and light strobes. The camera illumination controller will define the strobe duration that will be used to drive the light source, and the exposure time that will drive the co-express triggering mechanism that has a jitter compensation to remove any transmission jitter. Note that the control loop between the conveyor movement, the light strobe, and the camera trigger, it's closed inside of the frame grabber's FPGA without any interference of the host PC, which make it extremely precise with no latency and no jitter. Additionally, it's also possible to synchronize multiple frame grabbers with the C2C link. Now, a more specific feature for high-performance machine vision applications called DMA de-interlacing. The DMA de-interlacing can be used for line scan applications where each line is exposed alternating 2 different light sources. To process this kind of image, the application will usually need to proceed some memory copies in the host PC, which takes time and CPU resources. To avoid that, we introduced this feature where the de-interlacing is done at the DMA level. It means without any memory copy and CPU processing. The result is that the Euro application will directly receive two buffers, one for each light source. We have demonstrated this function a few months ago at the Automate show in Detroit. In this demonstration, we used two lights interleaving dark field and bright field illumination on a battery foil inspection application. So the camera acquires one line from the dark field lighting, then one line from the bright field lighting, and so on. And then the job of the Coaxlink card is to separate these lines coming from the camera and store them into two separate images in the host memory. The onboard frame buffer is an essential feature for high-performance machine vision applications. It is the onboard frame buffer that will guarantee a stable acquisition without any frame lost. To explain that, this example shows the data path between the camera and the host PC memory. So the camera in this case provides up to 12.5 gigabytes of data. All this data is passed through the onboard frame buffer. Then the data is immediately available to the DMA engine that will write this data into the host PC memory. Optionally, the DMA can also write the data direct into the GPU memory. Usually, PCs cannot guarantee full PCI bandwidth all the time due to other devices on the same root port or switch, and also due to concurrent workloads inside of the PC, causing fluctuations on the bandwidth. In these cases, the onboard frame buffer will absorb these fluctuations to guarantee that no frame is lost during the acquisition process. Another important function present in the Coaxlink frame grabbers is the capacity of accelerating inspection applications by offloading pixel processing tasks from the host PC. Our frame grabbers offer a set of onboard pixel processing functions, including flat field correction, Bayer decoding, pixel binding, etc. So in this example, I try to illustrate this process. We have the same data path as before, where the camera stream is decoded by the CoExpress core, then the data passes through the frame buffer and feeds the pixel processing module with the original image provided by the camera. In the pixel processing module, we can apply a flat field correction to correct the non-uniformities due to the lighting. Then we can apply a lookup table to improve the image contrast, and finally a pixel binding to increase the pixel dynamics and reduce the image size. The result then is directly written into the host PC memory, where the actual inspection application can then concentrate the processing power in the high-level inspection tasks like measuring objects. So now let's take a quick look at the Coaxlink software environment. We have a whole software framework that is distributed with our products, starting with our eGrabber driver that has a modern and user-friendly object-based API. It is full compliant with GenICam, supported on Windows, Linux, and macOS for both ARM and 86 architectures. The API is compatible with C++, C#, Python. It's supported by third-party image processing libraries. And it also supports direct DMA to GPU for applications that requires extra processing power. Then we have the eGrabber Studio, that it's a very powerful image acquisition software. The eGrabber Recorder, that it's a video recording library. And the eGrabber PlayLink, that can play eGrabber recorder containers as a virtual frame grabber with camera. We have also Memento, that it's our eventing logging tool. So now what's next after the Coaxlink QSFP28? Currently, we are working on the Coaxlink Octo 6p12 frame grabber. It will support 10 gigabytes per second of camera bandwidth with 8 6p12 connectors. It is equipped with a PCI Express Gen 4 by 8 and 8 gigabytes of onboard memory for frame buffering. With 8 6p12 connectors, we can create very compact and cost-effective systems. With a single board, we can support up to 8 6p12 cameras, and it can also support several other camera combinations, like 5 cameras where one camera has 4 6p12 connectors, and the other 4 cameras have 1 6p12 connector. The plan for this board is to have the first evaluations beginning of next year and the official launch mid-2026. So that's it. Thanks. Back to you, Basti.
Can we use fiber optics in an industrial environment?
Yes. So this is a very common question, because fiber optics were always seen as a very fragile component. But in fact, today we have very different technologies for fiber optics, like high flex fiber optics that can support thousands and thousands of bending cycles, and other fiber optics with a shielding that can protect the fiber core from mechanical pressure. So the answer is yes. Today we can use fiber optics in the industrial environment.
Okay, thank you. One more question for you. Is there any co-express camera that can provide 100 Gbps of data?
Yes, in fact, there is a number of camera makers working. Some camera makers already released their 100G version of co-express fiber camera, and other camera makers are working on their products. But yes, today we can already find in the market cameras using co-express fiber at 100G